ሰላም ተማሪዎች እንዴት ናችሁ? እሸቱ ነኝ የዘጠነኛ ክፍል የሂሳብ መምህር ከሉሲ ብሪጅ አካዳሚ። ዛሬ የምንማረው ኦፕሬሽን ኦን ሴትስ especially complement and symmetric difference of a set. Okay, as you remember on the previous period we have discussed about equal sets, equivalent sets, union and intersection, and today we are going to see complement and symmetric difference. ከዛ በፊት ግን እንደተለመደው ዌብሳይታችን lucybridgeacademy.com እየገባችሁ የተለያዩ ጥያቄዎችን፣ አጫጭር ኖቶችን እና ከ5 በላይ ቋንቋዎችን መረዳት የሚችል personalized AI assistant ፕላትፎርም ታገኛላችሁ። ስለዚህ ጆይን ማድረጋችሁን አትርሱ። እንዲሁም ለሌሎች ተማሪዎች በስፋት እንድንዳረስ የቴሌግራም ቻናላችን ጆይን አድርጉ፣ የዩቲዩብ ቻናላችን ሰብስክራይብ አድርጉ። So let me go to today's lesson. Operation on sets, especially complement of sets and symmetric difference of set. Complement of a set, a complement of a set, A denoted by a complement, is a set of all elements in the universal set U that are not in A. You see, a complement. When we say a complement, every element in what? In U, not in A. In U, not in A, or in the universal, not in the given set A. A complement, okay? Let me show you diagrammatically. Assume this is our universal set. The box represents the universal set U, and assume we have a circle, and the circle represents set A. A complement indicates the shade region, okay? The shade region. Look, all this region represents a complement. A complement is every element in the universal set, but not what? But not in A, out of A, but in what? In the universal. That is what we call it a complement. Symbolically, a complement can be described using set builder method. X an element of the universal set, but X not an element of the given set A. Okay, example, if the universal set is equal to the set containing 1 2 3 4 5 6 and A contains 2 4 6, then A complement is 1 3 5, because 1 3 5 is in U but not in A. Okay, let me again describe this set using diagram. Okay, 1 3 5 2 4 6 is in A, 2 4 6 is in set A. This is our set A, and we have universal set U. Again 1 3 1 3 and 6, 1 3 1 2 3 4 5. Look, the universal set contains every element 1 2 3 4 5 6, both in the box and in the circle is included in the universal set U, whereas 2 4 and 6 is elements only in A. 2 is in A, 4 is in A, 6 is in A, but 1 3 and 5 are not in A, but they are in what? In U. That means 1 5 3 is not in the given set A, but 1 3 5 is in the universal set. Therefore, A complement means not in A, but in the universal set, which is 1 3 5. Again, we have another example. The universal set A B C D E, it contains all elements. Look, it contains the universal set. Again, we have set A. Set A contains A, C, and D. This is the circle represents set A. In the universal set, A, B, C, D, and E. Okay. Look, the universal set contains the letters, the small letters A, B, C, D, and E. But the set A is in the universal set and it contains A, C, and D. Therefore, the complement, A complement means A complement is equal to all elements in the universal set but not in A, which is B and E, right? B and E are elements of A complement. The union of A and A complement gives us what? A. Don't forget that. Okay, the union A complement gives us the universal set. Okay, properties of complement. The complement universal set is the input set. Okay, the complement of U. Okay, the complement of U. As I have told you before, the universal set includes all sets, or it includes all elements. Okay, so U complement means in U, not in U, but out of U. No such elements. Alright? ከዩኒቨርሳል ሴታችን ውጭ የሆነ ኤሌመንት የለም። therefore U complement ማለት input set ማለት ነው። U complement means U complement is equal to input set. Alright? It is an input set. Right? No element is out of our universal set. Again, input set complement. Input set complement means the universal set. Input set complement is the universal set. Take the complement twice gives the original set. Yeah, A complement gives us A. We will see example ተጠቅመን እናያለን. A complement gives us set A. Look, the universal set contains 1, 2, 3, 4. Okay, so what is A complement in this case? A complement. A complement is in the universal set but not in A. All elements in the universal set not in A. 1 and 2 is in A. Therefore, 3, 4 is in A complement. 3, 4. These are elements of A complement. All right. What about the complement of complement, which means A complement again complement. A complement. Right. That A complement means elements not in A complement but in the universal, which is what? Which is out of 3 and 4, not 3 and 4, which means 1, 2. Alright? 1, 2. This means set A, alright? So A complement is A. Okay. Next, symmetric difference of sets. Symmetric difference of sets. The symmetric difference of two sets A and B. The symmetric difference of two sets is the set of all elements in A or B, not both, not in both, right? Either only in A and only in B. That means asymmetric difference B means asymmetric difference B. Asymmetric difference B, it means A union B minus A intersection B. Is that clear? A union B minus A intersection B. Or asymmetric difference B means asymmetric difference B is equal to X such that X is either in A or in B but X is not in what? In both A and B. That means A intersection B. Intersection B. Look, example. If A contains elements 1, 2, 3, B contains 3, 4, 5, then asymmetric difference B means, look, we have to exclude common elements. Intersection የሆነውን ኤሌመንታቸውን exclude እናደርጋለን. That means 3 is in A, again 3 is in B, therefore 3 cannot be symmetric difference of A and B. That means asymmetric difference B is 1, 2, 4 and what? 4 and 5. 1, 2, 4 and 5. We have to exclude the common elements in the case of symmetric difference. Next, let A is equal to X, Y, Z. The set contains X, Y, Z, and B contains Y, Z, W. So we are asked to find the symmetric difference of the two sets A and B. That means A symmetric difference B is equal to Yes, x is in A, x is not in B. Therefore, x can be an element of the symmetric difference, right? Again, y is in A, y is in B. Y cannot be element of asymmetric difference B. Z is in A, again Z is in B. Therefore, Z cannot be an element of what? Asymmetric difference B. The only element is x, because x is only in A, not in both. Therefore, the symmetric difference of A and B is the set containing x. Diagrammatically, let me show you diagrammatically ወደፊት asymmetric difference B በዲያግራም ምን እንደሚመስል በደንብ ማወቅ አለብን። The first circle represents set A, the second circle represents set B. Now, look this part, this shaded part. This part is A minus B, all right? A minus B. Only those elements only in A. Again, this shaded region, this part. This part is only B. That means B minus A. Or B without A. Simply, we can write B without A. Only in B, not in A. What about this part? A without B, only in A. Therefore, the union of these two regions gives us a symmetric difference, okay? So, asymmetric difference B is equal to A without B, or A minus B union B minus A. That's it. A minus B union B minus A, or we can write like this: A without B union B without A. Or asymmetric difference B means the union of the two circles, which means A union B minus their intersection, A intersection B. Common የሆኑ ኤሌመንቶች asymmetric difference B ላይ አንወስደውም። This the unshaded region is A intersection what? Intersection B. So this is a very important concept in the case of symmetric difference. If two non-empty sets A and B, so the symmetric difference of A and B, or asymmetric difference B, means A union B without intersection B, or A union B minus their intersection, or those elements in A, only in A, and only in B. That means A without B union B without A. That's it. Applications of complement and symmetric difference. Now let me see the application part. Okay, we use complement and symmetric difference to solve practical problems. All right. So complement is useful when solving problems involving not conditions in probability and logic. Again, symmetric difference is used in data comparison elements in one set but not both, as we have discussed before. Once we understand the concept of symmetric difference, it's difficult to solve practical problems. We apply the concept that we have seen before, right? This operation help simply real-life problems like survey, analysis, and classification. Look, let me show you using diagrams, symmetric difference, right, and complement. Assume this is our universal set U, and assume we have two circles, circle A and circle B. Circle A and circle B. Now, let me take X, Y, Z, and R. Now, X means assume that number of A without B represented by X. That means elements only in A represents X. X is the number of elements only in A, or A without B. Again, number of B without A number of elements only in B, not in A, represented by Z, and the number of their intersection, the intersection B, is equal to Y, and R is number of A union B complement represented by R. Okay, A union B complement. What do you mean by A union B complement? A union B means the two circle, right? Complement means out of the two circle, but in what? In the universal set, which is R. R is in the universal set, but not in A and in B, right? Okay, so in this case, the number of the universal set, all elements gives us what? X plus Y plus Z plus R. X plus Y plus Z plus R gives us the whole sets. That means the universal set. The number of universal set is X plus Y plus Z plus R. That means A without B plus A intersection B plus B without A plus A union B complement. This means number of A without B plus number of A intersection B plus number of B without A or only in B plus number of A union B complement. Okay, A union B complement. The sum of this gives us the total number of population or the total number of sets. In a survey of 40 students, look example, in a survey of 40 students, 25 like tea, 20 like coffee, and 10 like booze. How many students like tea only? Look, use the previous diagram. እንደዚህ አይነት ጥያቄ ሲሰሩ ልጆች ይሄንን ዲያግራም በደንብ መረዳት ይኖርባቸዋል። አሁን እዚህ ጋር ያሳየዋችሁን only A, only B, X is only A, Y is only B, and Z is only B, and Y is common element in both A and B. R is the complement of the two circle. That means R is out of the two circle, but in the box. It means R is in the universal set, but not in A union B. So in diagram በመጠቀም ሁሌም ማንኛውንም አይነት ፕራክቲካል ፕሮብለሞችን ስፔሻሊ ሰርቬይ ፕሮብለሞችን በቀላሉ መስራት ትችላላችሁ ማለት ነው። አሁን በዚህ መንገድ ላስቀምጥላችሁ። We have circle A, circle B. Okay. Like T, A, it's better to write T means those students who like T, let me represent by T, all right, T. And those students who likes coffee, let me represent by C. Okay, so 10 students like both. That means there's a T intersection C means 10. There are 10 students who likes both tea and coffee, right? Look, but 25 students like what? Like T. That means here we have X and here is Z, right? X plus Z. Look, X plus Z. X plus Z. X plus Z gives us what? 25. That means those students who like T and not X plus Z, X plus 10, sorry. X plus 10 gives us 25. X is equal to 25 minus what? 25 minus 10. X is equal to 15. 15 students like only T, and 10 plus Z or Z plus 10. Z plus 10 is equal to 20. That means 20 students like coffee, right? That means Z is equal to 20 minus 10. So Z which is equal to 10. So Z means those students who like only coffee, and X means those students who like only tea, right? That means, look, now X is 15, and Z is 10. That means in circle T, those students who like tea, yes, that means 15 plus 10, 25 students like tea. And circle C means those students who like coffee, 10 plus 10, which is 20 students like coffee. But those students who drink both, who likes both coffee and tea, is 10. Their intersection is 10. Okay, so how many students like tea only means the answer is what? 50. 50 students. 50 students like only tea. Yes, only tea. Okay. Question: what is the complement of the universal set? The complement of the universal set, as we have discussed before, is empty set, right? Again, how does asymmetric difference be differ from the union? Look, asymmetric difference means asymmetric difference B is equal to asymmetric difference B means A union B minus A intersection B. Asymmetric difference B means A union B minus A intersection B. That's it. Give a real life situation where complement is useful in problem solving. Okay. Complement. Look, the previous example. If the question, how many students like neither coffee nor tea? የሚል ጥያቄ ብንጠይቅ ሻይም ቡናም የማይወዱ ልጆች ምን ያክል ናቸው የሚል ጥያቄ ብንጠይቅ ይሄንን ስንደምረው 15 ሲደመር 10 ሲደመር 10 35 ተማሪዎች ናቸው። ጠቅላላ ተማሪዎቹ ስንት ናቸው? 40 ናቸው። 40 ስለዚህ አምስቱ እዚህ ውስጥ ይገኛሉ። ይሄ ማን ነው? r ብለን አላልቀደም? ያ r which is equal to 5. 5 means those students those students who likes neither coffee nor tea. Okay, ቡና ሻይም የማይወዱት ልጆች ስንት ናቸው ማለት ነው? 5 ልጆች አሉ ማለት ነው። ያ ማለት A union B complement ማለት A union B complement, you see, complement which is equal to 5. ሁለቱንም የማይፈልጉ ግን ምን ውስጥ ያሉ ዩኒቨርሳል ከተማሪዎቹ ጋር አብረው ሁሉም ተማሪዎች 40 ናቸው። ከ40ዎቹ ውስጥ 5ቱ ቡናም ሻይም አይፈልጉም ማለት ነው። ሻይ ብቻ የሚፈልጉት 15 ተማሪዎች ናቸው። ቡና ብቻ የሚፈልጉት 10 ተማሪዎች ናቸው። ሁለቱንም የሚወስዱ ደግሞ 10 ተማሪዎች ናቸው ማለት ነው። ሶ ኮምፕሊመንት አሁን ባልኳችሁ መንገድ practically apply እናደርጋለን ማለት ነው። This is all for today. On the next video we will continue other application parts of sets. Okay, የቀሩን የአፕሊኬሽን ፓርቶች ይኖራሉ። እሱን እንቀጥላለን። ከመሰናበታችን በፊት ግን ማንኛውንም አይነት ጥያቄ፣ ኮሜንት፣ ሰጀሽን ከቴሌግራም ቻናላችን ላይ ከማስቀመጥ ወደ ኋላ እንዳትሉ። እንደተለመደው የሂሳብ መምህራችሁ እሸቱ ነኝ። ሰላም ሁኑ።